All right, hi everyone. So glad you could all join us today. So if you were here for the live class, you would probably remember us having a few technical difficulties at the beginning of the lesson, and the first 10 minutes or so didn't actually get recorded. So this is just a re-recording. We do have a few things to iron out, but hopefully everything will run well by the next lesson. So we have a lot to get through today. Let's get started. Oh, before I begin, I would like to give an overview of this course schedule. So hopefully you all got an opportunity to look at the schedule. So this course is pretty condensed. We're going to be going through these units pretty quickly. So if there's ever anything you don't understand, the polynomials unit is often quite difficult, but feel free to rewatch our videos over again. There are also going to be lots of online resources that we'll link to in the drive. So this course is going to be 12 lessons long with one lesson every week. So we're actually scheduled to have our last lesson on November the 20th, about a month before the end of the semester. Anyways, let's get back to the slide. So today we're going to be going over our first unit, which is all about measurement. This unit is split up into two parts. So part 1, metric and imperial systems, and part 2, surface area and volume. In some textbooks, this is actually 2 different units, so keep that in mind when you go to school. So we're going to go over the first one. I'm going to introduce you all to the metric system. So this metric system is known more formally as the SI system. SI stands for Le Système International d'Unité. I don't speak French, but if you do, you would probably understand what this means. So this system is based on the meters. All the other units are multiples of tens of that meters. I want to pull up a table so you guys can better understand. Over here, we can see that it starts on the meter. And if you have 10 meters, you get to a decameter. And if you have 10 decameters, you get to a hectometer. 10 hectometers, you get to a kilometer, and so on and so forth. And the same goes for the other way. So if you have 1/10 of a meter, you get a decimeter. 1/10 of a decimeter, a centimeter. 1/10 of a centimeter, you get to a millimeter, and so on and so forth into the negatives. Or sorry, not the negatives, the fractions. It does look like a lot of units at first, but the 3 main ones that you'll have to remember are the kilometers, the centimeter, and the millimeter. These are the ones that we'll be using most often in daily life and in our conversions. Let's go back to our slide. So at the bottom, just remember these conversions. Now I'm going to introduce you all to the imperial system. So this is quite an old system. In ancient times, people used different parts of their bodies to measure. So their thumbs, their feet, their arms, and even the distance walked in 20 minutes. So they used all these different ways of measuring. And while everyone did have, or hopefully everyone did have a thumb and a foot, the problem with the system is that it's quite difficult to convert between units. So if you look at the bottom, these are the conversions, you can see that the units seem quite random. So 1 foot is equal to 12 inches, 3 feet is equal to 1 yard, 1,760 yards is equal to 1 mile. Like, how in the world are we supposed to memorize this number? Well, a lot of people think of 1,760 as a year. So year and yard both start with the same letter. So hopefully that will help you remember. At the bottom, you can also take a look. This number, wow, 5,280 feet in 1 mile. For this number, a lot of people like to say each of the digits separately, so 5280. And if you say it quickly, or it'll start sounding like 5 tomato. So 5280, 5280, 5 tomato. Hopefully this helps you. So let's do a quick recap. What units would you use to measure the distance between 2 cities? Well, we're assuming the distance between 2 cities is very, very far. Obviously, we would like to use something like a kilometer or a mile to measure. What about the height of a telephone pole? Now, this is not as long as something like a distance between 2 cities, so you would most likely use meters or yards. YDS is just an abbreviated version of yards. About the length of the table, most likely centimeters or inches. And for the diameter of a thin electrical wire, maybe millimeters. And as for the imperial system, most people use fractions of inches. All right, let's move on. All right, so now we're going to do a few conversions between units. What we have here is something called a unit conversion factor. So how we convert is, over here we want to convert 7 yards to miles, right? So we first have to remember how many yards in a mile? 1,760 yards is equal to 1 mile. Oh, forgot the I. So in order to do this, we first want to write down the unit that we want to convert, which is 7 yards. And we want to multiply this by a fraction. In order to help you better understand, I want to turn the 7 yards into a fraction. So I want to make it over 1. What we want to do is we want to cancel out yards and then leave miles as the unit. So if we want to cancel out something, what we do is put that number in the denominator. So we have 1 in the numerator, 1 in the denominator, and they can cancel out. That means we put the remaining unit in the top for miles. And if we look back to our conversion, we can remember that there's 1 mile for every 1,760 yards. Now it's just a matter of canceling out units and a calculation. So let's grab our calculators. 7 divided by 1,760 is 0.0039 blah, 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 blah. Wow. Let's round that up to the hundredths place for convenience. That'd be 0.004. And don't forget the units, miles. Now over here, we want to convert feet to inches. This is a relatively easier conversion. What we want to do is the same thing, write down our unit that we want to convert, and then multiply it by the unit conversion factor. If we remember that there are 12 inches in 1 foot, it makes it really easy to find what numbers we have to input in our unit conversion factor. So now it's once again a matter of putting in your calculator. 31 times 12 is equal to 372, and the units, inches. All right, let's move on. So now comes the difficult part. And we have to learn how to convert between SI units and imperial units, because big countries like the US do still use imperial units. So it's important that we know how to convert between those two. On the left, you can kind of see a big table full of all these conversions and numbers. It might look really intimidating, but I'm here with good news. You don't have to memorize this. The most important thing that you do need to memorize, though, is that 1 inch is equal to 2.54 centimeters. So this is kind of like the bridge between imperial and SI units. Well, so keep in mind that the SI system and the imperial system have no correlation. So the conversions are not going to be nice numbers. Even in this, it's not perfectly accurate. So in reality, there are actually more decimals behind this. So it's 2.54 with a bunch of decimals after it, but we rounded up to 2.54 for convenience. Actually, some teachers even rounded up to 2.5, so it's really depending on your teacher. Now we're going to get to practice our conversions for a bit. So over here we have 4 students, and we want to find out who is the tallest and who's the shortest. So right now, their heights are all in different units, so we're going to have to convert them to a single unit, or to 1 unit, to better kind of compare. So in Canada, we often measure height in centimeters, so we're going to convert them all to centimeters. Since Sam is already in centimeters, we can leave that alone. But for Dan, he's actually written in, 2 units. So he's 5 foot 7 inches. In order to convert that to centimeters, we first have to convert 5 foot 7 inches to a single unit. So let's convert that both to inches. Now, since 7 inches is already in units, or already in inches, we can put that aside and just convert 5 feet to inches. Now, 5 times 12 is equal to 60. So there are 5 feet. In 5 feet, there are 60 inches. Now, we can't forget about the 7 that we put aside earlier. So let's just add that back in. And we get 67 inches. But we're not done here because we still have to convert from inches to centimeters. So we have to multiply this by 2.54 which will give us, let me put this in my calculator, 170.18 centimeters. Don't forget the units. Teachers can deduct points in quizzes and tests if you forget. As for Amanda, her height is written in yards. So we want to convert first from yards. Let's convert it to inches. So there are 36 inches in a yard. So we want to multiply this by 36. 1.7 times 36 is 61.2. Now that we have it in inches, we want to convert from inches to centimeters. So once again, we're going to multiply by 2.54, which will give us, times 2.54, 155.448. Yeah, these numbers are not pretty. Like I said earlier, the conversions will not always be very nice. Lastly, we have Lloyd, and his height is already written in SI units, but we just have to convert from meters to centimeters. And this is relatively easy. We just have to multiply by 100 to get 177 centimeters. So now that we have everyone's height in centimeters, it's really a matter of ordering numbers from biggest to smallest to figure out who's the tallest. Aha, a rhyme. If we look here, we can see that 177 centimeters that from Lloyd is the biggest number. So we know that Lloyd is the tallest, and second is Sam, and then Dan, and then Amanda. All right. Let's move on to part 2, surface area and volume. Before we move on, right, this is really important. Sometimes you might be given values in different units and asked to find the surface area or volume. So for example, maybe you're given a rectangle and the length you're given, let's say 3 centimeters, and the width is 5 inches. So you can't just multiply the length times the width. So you can't just multiply 3 centimeters times 5 inches. You have to first convert them both to a single unit, to the same unit, sorry, whether it's centimeters or inches, and then you can multiply it. So this section is very, very formula heavy. You're going to be introduced to a lot of new formulas. It's best for you to memorize them because it will make calculating it easier, but of course you don't have to. Now we're going to kind of talk about surface area and volume and the differences. So surface area is the sum of areas on the outside of an object. So if we look at a human body as an example, the surface area of a human body would be your skin, anything in contact with the outside environment. In volume is the space that the object occupies. So back to our human analogy, the volume of human would just be the entire body. That would include all your skin, your organs, your muscles, all of that. Your body itself is the volume. Over here, we're going to kind of review a few basic shapes. You've already learned about the squares, the circles, and the rectangles and triangles. Now, these are all 2D shapes. They don't occupy any volume. So the shapes like these, you aren't able to calculate the volume because they're only 2-dimensional. Now, if we take, for example, a ball, a soccer ball, and let's say we dunk it in a bucket of water, what's going to happen? Well, the water level is going to rise. And this is because the soccer ball takes up space. It has volume. When you put it in the water, the soccer ball is going to push aside the water, and the water is going to go up because it has nowhere else to go. The soccer ball is displacing the water. Now, if we look at a 2D shape like a square, well, first of all, it wouldn't really be possible, but if we were going to try to dunk a square into a bucket of water, nothing is going to happen. And that is because a square is a 2D shape. It has no volume. It's a plane. So it wouldn't displace any water at all because it really only has area, no volume. So over here, we're gonna kind of look at some unit conversions of area and volume. Oh yes, the unit conversions. So I want you all to remember that area is measured in square units and volume is measured in cubic units. So what that means is a square unit let's say a centimeter, a unit, it'll have a tiny 2 at the top, meaning that it's squared. Over here, there are examples. This is a 9-foot squared, and a cubic unit will have a tiny 3 at the top, meaning it's cubed. Over here, we're going to kind of explore two objects. So one is a cube and one's a rectangular prism. So these shapes both have 6 sides. A cube's sides are congruent, meaning that the length, the width, and the height all equal to each other. And so we can assign a single variable for them all. Let's just say S, which stands for side. But for rectangular prisms, it's a bit more different. It's a bit different. So each of these sides can be the same as cube, but they're probably different because, well, it's a rectangular prism. So I'd like you all to remember that all cubes are prisms, but not all prisms are cubes. Over here, we're gonna kind of figure out the formula for each of these. So in a surface area, to calculate the surface area of a cube, what you would do is just find the surface area of a square, and then multiply it by 6 because there are 6 sides of that cube. And that's the formula for the square, just 6s squared. For the volume, it's even easier. So a lot of the times calculating volume is actually easier than calculating surface area. In this case, it's just multiplying the s by itself 3 times. So s times s times s, aka s cubed. We're going to learn more about exponents in a later unit. So now we're going to do a few calculations. Over here, we want to calculate the surface area of a cube. Our formula is right up here. So, but keep in mind, read the question carefully. It wants the final answer in centimeters squared, which means that we first have to convert this side length, which is 5 in feet, to centimeters. So we want to just first convert 5 feet to inches. 5 feet is equal to 5 times 12, 60 inches. And then we want to convert inches to centimeters. So 60 times 2.54 equal to 152.4 centimeters. Now that we have our side length in centimeters, we can input in the formula. Surface area is equal to 6 times 152.4 cm squared. And let me input this in the calculator. This is equal to 139,354.56 centimeters squared. Oh yes, now we're going to explore a few more complex shapes. We're going to take a look first at the pyramid. So over here we have a little diagram of the parts of a pyramid. At the bottom we have the base, and there are 4 faces, triangular faces, and at the top there's something called an apex, which is just a fancy word for the tip, sorry. Over here, it also tells you the height. Now, there's something really, really important that you have to remember. This height is not the same as this height. This height is called the slant height, and it's the height of the triangle. But this height is the height of the pyramid. So you can actually see that if we drew out a right triangle in the bottom, you could see that the slant height is actually longer than the actual height of the pyramid. There's something you probably learned earlier called the Pythagorean theorem, and you can use that to calculate the slant height. So in case you forgot it, it's a squared plus b squared is equal to c squared. So in any case where you're given 2 of the sides, you can always figure out the third side. A very famous Pythagorean triple is 3, 4, 5. So one side is 3 units long, one side is 4 units long, and the hypotenuse, which is the longest side, is 5 units long. If we put these numbers into the Pythagorean theorem, we would see that it was true. But so 9 plus 16 is indeed 25, and therefore both sides are equal, and therefore this statement is true. All right, so now we're going to kind of look at the surface area and volume of square and rectangular pyramids. So in a square pyramid, all of the sides are equal. So the base is a square. but you have to remember that the sides are not necessarily equal to the slant height. They can be, but not all pyramids will have the same side lengths as the same slant heights. Now, we also want to remember that the slant heights are equal, but the slant heights are not equal to the side lengths. So, oh yes, over here is a rectangular pyramid, and it's very similar to a square pyramid, except at the bottom we have a rectangular base instead of a square one. So, in the case of a rectangular pyramid, you actually have two different slant heights because one side will be longer than the other. For these two shapes, we do have a formula. Surface area is equal to the area of the base plus the area of the sides. Pretty intuitive. Yes, the surface area is just the bottom plus the base plus the four sides. Now for the volume of the pyramids, it's really just, imagine a cube with the same dimensions as the pyramid, but the pyramid is a third of the cube's volume. Now, if you want to see proof, you can try it at home. If you happen to have a pyramid cup and a cube cup with the same dimensions, then you could try pouring in water or some sort of liquid into the pyramid cup and pouring the liquid from that pyramid cup into the prism cup, and you'll see that the water makes up exactly 1/3 of the prism. And thus we have the formula volume equals 1/3 length times width times height, or length times width times height divided by 3. So over here, we are going to do some calculations. We want to find the surface area and the volume of this square pyramid. We don't need to convert any units, but if you're taking this course at school, it's very likely that your teacher will make you do a lot of these unit conversions. So we're just going to put down the formula for the surface area, which is just surface area times the area of the base times the four triangles. And if you remember from grade 9 math, the area of triangles is base, which is in this case 8, times height, which is 7, divided by 2. Remember, this slant height is not the same as the pyramid height. You can see that the numbers are different, so don't get them confused. Remember to differentiate. So right now, Stephanie is inputting the numbers into the formula, and I'm going to put them into the calculator. So we're going to do 8 squared plus 4 times 1/2 of 8 times 7, which is 176. And the units, don't forget the units, are centimeters squared. All right, let's move on. Oh, sorry, we forgot to find the volume. All right, right, sorry. The volume of this pyramid is 1/3 of the length, which is 8, times the width, which is also 8, times the height, which is 5.75. So in this case, we're just going to input the numbers, 8 times 8 times 5.75 divided by 3. 8 squared times 5.75 divided by 3, which gives you 122.66666, going on forever. But we can round it up to, let's say, 67. It's rounded to the hundredths place. All right. Yeah, the computer's a bit lagging. It's lagging just a tiny bit. Oh yes, don't forget the units at the back. But instead of squared, because we're calculating the volume, we're going to use cube. Yes, now we're going to introduce this this shape that I don't think has been introduced yet in Math 9, but it's the cylinder. So we're going to first try to find the formula for the surface area of the cylinder. Now, if we imagine unraveling the cylinder, we're going to find that the cylinder is composed of 2 circles and a rectangle. Now, these 2 circles, hopefully you remember the formula for calculating the area of a circle, pi r squared. Now, since we have 2, we're going to multiply pi r squared by 2. And the rectangle is just length times the height. Now the height is usually given, but for the length, you notice that this length is actually the same as the circumference of the circle. Now, the circumference, the formula for the circumference of the circle is just pi d, or pi 2r, 2 pi r. So once you have 2 pi r, you just multiply by height to get the area of the rectangle, and then you add the two circles to that, and you get the surface area of the cylinder. Now for the volume of the cylinder, like I said earlier, calculating volume is usually easier than calculating surface area. What you do is just calculate the area of the circle and then multiply that area by the height. So pi r squared times height. Let's do some practice questions to kind of test our knowledge. Over here, we want to calculate the surface area and volume of this cylinder. So let's first write down our formula for the surface area, which is just the two circles plus the rectangle. So 2 pi r squared plus 2 pi r times height. Now, pi is a number, so we don't need to input anything in there, but for the radius, it's given, it's 5 feet. We want to first square that radius and then multiply by pi and multiply by 2, which will give us 2 times pi times 5 squared plus the rectangle, which is 2 times pi times 5 times 12. And once you add it all together, you get 5. Sorry, I'm a bit slow on my calculator. You get 534.0707 blah blah blah, but let's round it to the nearest hundredth, which would make it 534.07. And our units, which is feet, plus squared. Now for the volume, we're just gonna once again plug in our numbers. So at the top there's a formula sheet, but we're gonna do pi times the radius, which is 5, squared. Remember, only square the radius, don't accidentally square pi. So if you're using an old calculator, you might have to put brackets around the radius. Times the height, which is 12. Now, after putting this in, you get 942.4779, blah, blah, blah. We're going to round that to the nearest hundredth, which would be 942.48. And the units, feet cubed. All right, now we're going to work on, well, some spheres are kind of some of the hardest shapes to comprehend because you can't really imagine finding the surface area for a sphere, right? Because you can't exactly calculate a plane. It's not flat in any way. Since this is a bit harder to explain, we have a fun video for you where this guy, he measures an orange and tries to calculate the surface area of the orange by peeling off the orange peel. So yeah, that's what you have to remember. Surface area is equal to 4 pi r squared, 4 circles. Now for the volume of spheres, it's a bit more difficult to comprehend, but if you do imagine a bunch of pyramids, actually I'll just play this YouTube video. Now over here we're going to do a bit of calculation. So we're going to first find the surface area of the sphere with the formula that's at the top. Surface area is equal to 4 pi r squared. In this case, we really only need one unit, which is the radius, which is r. R in this case is equal to 8, so we just plug it in. 4 times pi times 8 squared, which is 804.24 and a bunch of decimals. So we're going to round that up to the nearest hundredth, which would be 804.25, and finally add our units, which would be centimeters squared. And for the volume, we're going to do the same thing, plug in our radius into the formula, 4/3 pi r cubed. A lot of people forget that the volume is you actually multiply the radius 3 times because you're going to the third dimension. So a lot of people tend to forget that, which would make their answer completely wrong. But it does make sense if you think about it, because this is a three-dimensional object. You do have to multiply the side length, which is that dimension, 3 times. So over here, we're going to have 4/3 times pi times r, which is 8 to the power of 3, which gives us 2,144.66, and the decimals, we can round that up. So 2,144.66 centimeters cubed. Now let's move on to cones. These are a bit easier to comprehend than spheres. So basically, kind of like the pyramids, the volume is 1/3 of a regular cylinder, and the surface area would just be this circle plus this, well, this is a partial circle. If you unraveled it, it would become kind of like something like a Pac-Man. But we're going to do a bit of calculations. Please do remember these formulas for school. You'll be doing a lot of them, so you'll probably end up remembering them after all those worksheets that your teachers are going to give you anyways. But over here, we're going to do some surface area and volume calculations. So the volume, which the formula you can see at the top, is 1/3 times pi times r, which is 5 centimeters. We square that 5, and we multiply by the height, which is 12. So if I put this into my calculator, pi times r squared times h, which is 12, and divided by 3, it would give us 314.16 centimeters squared. Now over here, we also, now in order to calculate the surface area, we're gonna have to find out the slant height, which is not given to us. So using the Pythagorean theorem, because we notice that this triangle is actually a right triangle. We have the height, which can be considered A, the radius, which can be considered B, and the hypotenuse, which we're trying to find, which is the S. So using the Pythagorean theorem, we can remember that A squared plus B squared is equal to C squared. And, oh, sweet, Stephanie already calculated it. The slant height is 13. We can input that into the formula, pi times 5 times 13 plus pi times 5 squared, which would give us 282.74 centimeters squared. Now moving on, since we have about a little less than 15 minutes left, and we do have a few more questions to go through. So most likely your teachers are going to introduce some more difficult shapes to you, not just aside from the regular cones and spheres, we're going to get some mixtures of those, so composite shapes. A common one that teachers might give you is this one. So over here, it might look really, really intimidating at first, but basically what we're doing is we're calculating the volume of snow used to make this main portion of the igloo. So the volume of snow would be basically the wall. Now, if we look at this carefully, we can find that there are actually 2 spheres that we can calculate the volumes of and then subtract them from each other. So this outer sphere, let's call it big sphere, so sphere subscript B. And this smaller sphere we can call small sphere, which could be just sphere subscript S. Now the volume that we're gonna use is just we're gonna subtract this small sphere, which is the empty space inside, from this big sphere in order to get the remaining wall snow. Wow, very scientific. So if you remember the volumes of the spheres, oh yes, one more thing that I should mention. So please note that this isn't actually a full sphere. It's actually only a half sphere. So we do actually have to divide both of these spheres by 2 in order to only get half of it. But putting that aside, let's calculate. You can hear my calculator noises in the background. After doing all these calculations, we get 5.14 and a bunch of decimals, so let's just round it up to 5.15, and the unit's meters, and the unit isn't just meters. We have to remember that it's a meter cubed, so we do have to add the tiny 3 at the top. All right, moving on. Oh yes, so over here we have received a souvenir from the International Games, and we want to calculate the volume of the souvenir. But so this souvenir, it tells us that is basically a cube smushed together with a sphere. So it tells us that this sphere replaces 1/4 of the volume of the cube. This is key information. What we can do is we can basically calculate the area of the sphere, or the cube, sorry, and then take out 1/4 of it, and then add the remaining to the volume of the sphere. So if we remember from our formulas earlier, the volume of a sphere, or a cube, is 4 times 4 times 4, the radius cube. That would be 64. And we want to take out 1/4 of this. So we want to multiply by 3/4, because if you take out 1/4, the remaining is 3/4. So you just want to multiply 64 by 3/4. And then now to calculate the volume of the sphere, we just multiply the radius. Oh, over here it doesn't actually give you the radius, it gives you the diameter. So we have to find out the radius, which is really just dividing the diameter into 2. So dividing 4 into 2, so the radius is 2. And then calculating with our formula, 4/3 times pi times 2 cubed, which would give us 33.51 and a bunch of decimals. Now we don't want to round it just yet, because we do want to get our number as pure as possible before the final answer. We only want to round when we've finished the entire question. So instead of rounding, we're going to add the volume of the sphere, which is, we're going to add this volume of the sphere directly to the number that we got earlier. So what we're going to do now is just 33.51 blah 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 plus 3/4 of 64, which would give you 81.51 blah 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 blah. Now we can round because we're at the final answer, so let's just round to 81.5 for convenience. And of course the units, centimeters cubed. And with this, we're done. We do have about 8 minutes left, so I do want to do a few practice questions. We will email you a recording as well as a copy of these slides, so don't worry if you were trying to take notes or anything. Don't feel rushed. We can give you all of these resources later. Hopefully you enjoyed today's lesson. Sorry it was a bit rough. We thank you so much for coming, and we hope you learned a lot. If you do have any questions, please email us or DM us on Instagram. We'll send you the video and all of the information afterwards.